Question 37, JAMB Mathematics. The nth term of the sequence minus 3, 9, and minus 7 and continues like that is dash. Let's see. Now, first of all, we need to first know what kind of sequence is this. What is even a sequence? A sequence is a set of number with a regular pattern of formation, maybe such that we are getting the succeeding terms of the sequence by addition or multiplying a constant by the previous term to get the next. Good. Now, that is a sequence. You need to know the difference between a sequence and a series. Sequence is separated. The terms of sequence are separated with commas like this. So they are separated with commas. But when I start adding them together, like minus 3 plus 9 plus the next, plus the next, plus the next, it becomes a series. That's the difference between a series and a sequence. Now, what kind of sequence is this? Let's know whether it is geometric progression or arithmetic progression. We need to know. Let's see whether it's something that they added to get the next term. So with the way we are even seeing this, it seems like a geometric progression, because any kind of sequence in which we produce next term by either multiplication or division, that's called a geometric progression. If I say 3 times 3, that will give me 9. 9 times 3, that will give me 27. 27 times next. So that means there is a common ratio between them. How do we get our common ratio? Common ratio R will be equal to T2 divided by T1. That is the second term divided by T, the first term, or T3 divided by T2, and it continues like that. So in this case, I can use 9 divided by minus 3, which will give me minus 3. That means my common ratio is negative 3. Now, they now ask for the general term, which is also known as the nth term or the last term. Now, T sub n equal to AR raised to power n minus 1. This is the general term of a geometric progression. This is the general term or the nth term, or we call it the we call it the last term in some cases. But in this case, the sequence does not end, so this cannot be the last term. So this is an infinite sequence. So in this case, let's substitute what we have. Our A represents first term, and the first term in this case is minus 3, and common ratio R is given below. That's minus 3. Let's substitute both in the formula. We have A as minus 3 times R, which is also minus 3, raised to the power of n minus 1. Good. Since these two numbers are the same, we can use the rule of indices to combine them. If two numbers of the same base, they are having different powers. If two numbers are this, if we have two numbers that are the same but they have different powers, the power on top of this is 1. Now, and the multiplication is connecting them. Just add their powers together. That means I can take one of these as minus 3 raised to the power of 1 plus the power on top of this, which is n minus 1. Let's write it in bracket. I can simplify for that as minus 3 raised to the power of 1 minus 1 plus n minus 1. Because if I open this bracket, so 1 and minus 1 cancel out. So I will have minus 3 raised to the power of n. That means T sub n equal to minus 3 raised to the power of n. Looking at the option, we see that option A is satisfied. Thank you.